is Muhammad Hafiz Hafizi bin Harun 211062660. So today I will explain the development and simulation of a pneumatic sequence control system for clamping and riveting operations using Automation Studio. In the setup, we use two pneumatic cylinders. The clamping cylinder A advances first to clamp the sheet metal components securely. Next, the riveting cylinder B advances while the parts are clamped to perform the riveting operation. After riveting, cylinder B retracts, followed by the retraction of cylinder A, completing the sequence. To implement this, I designed the pneumatic circuit in Automation Studio. It includes two double-acting cylinders connected to directional control valves. These valves are synchronized to ensure the proper sequence of operations. A advances, then B advances, followed by the retraction of B, and finally A retracts. In the simulation, you can observe how the sequence functions correctly. Cylinder A clamps the sheet, cylinder B performs riveting, and both cylinders retract in the specified order. This system demonstrates efficient control of a pneumatic clamping and riveting process, which can be applied in manufacturing environments.
Hello everyone, my name is Muhammad Zakwan Bezrani. Today I will explain the hydraulic circuit and how it powers the excavator. The hydraulic system begins with the pump, which pressurizes fluid from the reservoir. This pressurized fluid is distributed through directional control valve to the actuator that control the excavator movements. For examples, when the operator lifts the boom, the control valve direct fluids to the boom actuator. The fluid enter the piston side, extending the cylinder and raising the boom. To lower it, the valve reverses the flow and retracting the cylinder. Similarly, the arm actuator moves the arm upward or inward by directing fluid to the appropriate side of the cylinder. The bucket actuator works the same way, curling the bucket inward for digging or outward for dumping materials. Finally, the swing actuator rotates the excavator, allowing precise positioning. Each part works seamlessly, enabling the excavator to dig, lift, and move materials efficiently. The pressurized relief valve ensure the system stays safe from overpressure. That's all from me. Thank you.
So I will talk about the task tree. Basically, for the system of the task tree, we got 6 cylinder A to F. So when the start button is pressed, relay K1 active. Relay K1 will active. If the limit switch A0 is triggered, it will energize the solenoid Y1 to advance cylinder A. At the limit switch A1, relay K2 energize solenoid Y2 to retract cylinder A. Once the limit switch to A0, it's mid again. Solenoid Y3 advance cylinder B. Solenoid Y3 advance cylinder B. At the limit switch B1, relay K3 will energize the solenoid Y4 to retract the cylinder B. So when relay K3 and limit switch B0 are triggered, solenoid Y5 is active. Advance the cylinder C and C1. Advance the cylinder C to C1. At the C1, solenoid Y7 will move cylinder D to D1. Then with the relay K3 at the limit switch, D1 will active. Solenoid Y9 advance the cylinder E to E1. Once the E1 is reached, solenoid Y level advance cylinder F to F1. So finally relay K4 will K4 and solenoid Y10 will retract cylinder E. So when the limit switch of E0 active, solenoid Y8 will retract cylinder D to D0. When limit switch D0 and the relay K4 active, the solenoid Y9 advance the cylinder E to E1, trigger the solenoid Y12 to retract the cylinder F. Limit switch of F0 and the relay K5 will advance the cylinder F before solenoid Y10 retract cylinder E. So the limit switch of E0 active the solenoid Y6 to retract the cylinder C, and the relay K7 then advance the cylinder E, advance the cylinder E, retract, and they retract the cylinder F. So that is how the system work for the rock system for this task 3.